Alright guys, I think my voice is going out from doing all these videos, but let's move on to the second part of these equations of hyperbolas. Here's some examples, and on these examples they're not centered at 0, 0. You should make sure you have your little notes handy. I recommend having this because I'm going to be referring to it and reading off of it to help me remember what goes where and how things go. That's the wonderful thing about notes. They give you reminders. So we're going to do number 5. This is the second number 5 that's on the assignment. So you should go make sure you're on the second half where it starts over at 1 again. And we're going to do 5. So on 5, you need to get the center, the vertices, the foci, and the asymptotes, just like that one we did on the notes. It's got a lot of things you need to get. So it's going to take a bit. But first things first, it needs to equal 1. So let's divide everything by 100. Which will give us y minus 6 squared over 100. And then minus 5 out of 100 is 1 over 20. And it's going to equal 1. Awesome. So now that we have this, we can get our center right away because the values in here with x and y are the h and k values of our center. The number with the x is the h value, that goes first. The number with the y is the k value, that goes second. And now we have this, we can start working on these two things. To get the vertices, you're going to need a. Luckily, a squared is always under the first one. You know, a squared is 100, and that means a is going to be 10. Before you get your vertices, you do have to figure out if this is a horizontal or vertical one. And the way to tell is which variable is first. Y is first, so that means this one is vertical. And so we're going to take this, and we're going to take the y value, and we're going to be adding and subtracting 10. And that's coming from right here. The k value minus a and k value plus a is going to give us our vertices. So we got 4, 6 plus 10, which will give you 16. And then 6 minus 10 for the other one is going to be a negative 4. So we got our vertices. Hooray! Now we need to get our foci, and might as well change colors at this point. To get your foci, you're going to need C, and this does not give us C yet. You had to figure it out. Luckily, you know that this one is b squared, and if you look at your little note card here, notes, c squared is a squared plus b squared, just like the normal Pythagorean theorem. So we got c squared is 100 plus 20. We got our a squared and b squared values. Plug them in. So c squared is 120, which means c is the square root of 120. That is the precise value, and you can plug that in to your center. Again, since it's a vertical one, you're going to take your y value and add and subtract the c value. And that's from the notes here. All right, we got our foci, are these c values. Sorry, the vertex plus or minus the c values on the y part. And so that's going to give us 4, and then 6 plus root 120 and 6 minus root 20, which, let's just go ahead and get the decimal approximations so you can kind of see those. But it's going to be 6 plus root 120 and 6 minus root 120. Go ahead and plug those in. Alright, I got negative 4.95 and then 16.95. Hopefully you got those. The next part, we need to get the asymptotes. So the asymptotes are the equations that come from this little formula. It's y minus the k value, x minus the h value, and then you got your slope there, plus or minus a over b. And so I'm going to be doing some work over here to write my answer over here because it is two different equations. You got y minus 6 equals a, which is 10, over b, which is the square root of 20, which is not a nice number, square root of 20. I'm going to leave that in there for now. We'll do a decimal approximation in just a second. And then we got, wait, why am I in red? Green. I said green. In front of x minus 4. And so from here, this is a matter of simplifying. We're going to add 6. let's get a decimal approximation for this and then distribute it in. And we'll get y, and it's plus or minus, by the way. Y equals plus or minus something, something, something. Go ahead and plug in 10 divided by square root of 20 and then distribute it in. Alright, you should have gotten about 2.24. And so the rest of this process, it splits up into two different equations because you have two different slopes here. But you'll take positive 2.24 and distribute and simplify. And then you'll take negative 2.24, distribute and simplify. So go ahead and do that, and we'll have you check your answer in just a moment. Go ahead, do it. Do it now. Alright, you're looking at equations looking like these ones. Once again, it's just a process of distributing positive 2.24 to both of those, and then you'll combine those two terms together, and then you'll distribute negative 2.24 to both of those, and then you'll be adding 6 to the constant term. So you get these two values, and these are the asymptotes that go there. Not really nice numbers, but this was not a nice problem, which is why I wanted to do as an example for you. Let's do one that is quite a bit nicer and will be less messy numbers-wise. And that's number 9. This is the last number 9 in the assignment. You're supposed to write out the equation of the hyperbola that has these values. So it gives us right away, we've got some vertices, which means we can get our center. Center is just the halfway point, the midpoint between our vertices. The halfway between -4 and -4 is -4 for our y value. Halfway between 7 and 3, yeah, no, you get 4, divide by 2, you get 2. So it's at 2, -4. And since we have that, we can also get our a value. The a value is the distance from your center to one of your vertices. Between 2 and -3 is 5. So there's a, which means a squared is 25. And we also need to get our b value. Well, unfortunately, this focus doesn't give us the b value, but it gives us c. And if you remember, our Pythagorean relation is c squared is a squared plus b squared. And so that means if we have c squared, we can get b squared using our a squared as well. And so let's get our c value. C is how far it is between the center and one of your foci. Distance from 2 to -4 is 6. And so c squared is going to be 36. So using those, we can find the b squared, because c squared is a squared plus b squared for hyperbolas. Let's plug our values in. We got 36 equals 25 plus b squared. And now we can subtract 25, subtract some 25. You're looking at 11 equals b squared. So now we have a squared, we have b squared, we have our center, and so now we can write out the equation. Oh, we should probably also figure out if this is a horizontal or vertical ellipse. You should figure out which is changing, the x's or the y's. It's the x's. So this is going to be a horizontal ellipse. Not ellipse. Why do I keep saying ellipse? It's a hyperbola. And so, look at your notes. Find the horizontal one. That's this one. And you're going to be doing x squared first. And then a squared goes on the first one. So we got x minus our h value, which is 2. Squared. And then minus y minus the k value, minus -4, same thing as add 4. And then on the bottoms here, we're going to have a squared, which is 25, and then b squared, which is 11, and it equals 1. And congratulations, you have the equation of the hyperbola that has these vertices and these foci. Da-da-da-da. Good luck.